Hello guys, welcome back to Maison African Motives. In this case, we have got person that is on engineering science N3 for motion, power, and energy, or motion, energy, and power. So we are going to quickly rush through these typical questions from the question paper of August 2015. All right, so without wasting much time, we are given the first part, which is on 1.1, to sketch and describe displacement of an object. So take note here, the displacement of an object, okay? So in this case, I just want you to see how we can actually sketch this, okay? So this is what we are having from A, B, C, D. Then our displacement is this distance from the point A to the point D in this case, all right? So from the point of A to the point of D in this case. So we are referring this path here. This is the displacement, which simply means displacement is the shortest route from the ending to the starting point. So let's say we are given a journey or a route which was taken in this way, okay? And we have got the points in this case. Let's say this is our A, this is our B, and this is our C. Okay, I just hope it's clear. So if we are to talk about displacement, we are going to take from this point to the point of C. So it depends with the diagram that you have drawn, okay? So in this case, I just have this one. So the displacement is the shortest route from the ending to the starting point, or from the starting to the ending point. All right, so let's see the other part of the question that we are given in this case. Sketch and describe the difference between acceleration and retardation in this case. So remember that acceleration, it's an increase, okay? When you're increasing, where you have got a positive, and retardation, that's a decrease where you have got a negative in this case. All right, so I want us to check what we have in terms of a diagram in this case. All right, so let us check this part here. So we are given this part is our acceleration, which is the increase, okay? When there is an increase, and a decrease, that is your retardation, which is the deceleration. All right, so that is what you're given. So this part, acceleration A, is where the object will increase its velocity, and the retardation, that is the braking, is where the object will reduce velocity in that particular phase or period that you're given. All right, so that was it, guys. Let's move on to the other part. 1.3, we are given that a racing bike moves from rest and accelerates. Take note, we are starting from rest, where we know that our U is equal to 0. So starting at rest, and accelerates for 18 seconds with uniform acceleration of 8 meters per square second. Determine the displacement after 18 seconds. So it depends. You can actually use a graph, or you can just take the information. I'm just going to show you both ways. Okay, so the first part, we are given that this bike, racing bike, moves from rest. So from rest, we know that our initial velocity there is at 0. So this is 1.3. All right, so that's 1.3. So it's at 0 meters per second. Then what happened in this case? And accelerates for 18 seconds. We are given the time of the for this acceleration, which is 18 seconds. So our time in this case is 18 seconds. There is an acceleration that is taking place, and we are given with the uniform acceleration of 8 meters per square second. So we've got the acceleration now. So we are given the acceleration. So our acceleration in this case is given as 8 meters per square second. So the question is to calculate or to determine the displacement after 18 seconds, which is in this period of 18 seconds that we are given with these conditions. What is the displacement? All right, so displacement given by S, we can actually try and see from our formulas what is the best formula to apply or to use in this case to solve for S. So knowing that we've got a lot of formulas where there is S, we've got the formula of S, which is equal to U plus V over 2 multiplied by T. We have got the formula of S, which is equivalent to UT plus half AT squared. We have got the formula where also there is S, where we are given V squared is equal to U squared plus 2AS. So from these formulas where we have got S, at least there's a hope that we can actually determine this value of S. So which is the best formula depending with the information that we are given? We have got the initial velocity, the time, and the acceleration. So the best formula in this case is this one, where we have got U, T, and A. So we've got all these part here. So which means our S, which is the displacement, is going to be UT, whereby we said U, that's a 0. So it's going to be 0 times the time of 18 plus half AT squared, which is the acceleration of 8 times the time of 18, which is 18 squared. All right, so that is going to give us the total displacement of 1,296 meters. All right, so that is what you could have done in this case. Or we could have drawn a diagram, because remember that displacement simply means area if you're given a velocity time graph. Okay, so you could have drawn, because we started from rest, so it's actually an acceleration that is happening here. So we can just draw a diagram and see the shape that you're going to have in this case. So this is another method that we could have taken. So, or we can just have it this way. So let's say we have got our velocity time graph. In this case, this is our velocity, this side, meters per second, and we have got our time axis in seconds. So the object started at rest in this case, which means that's at 0, and accelerated to a certain velocity that we do not know in this case. That's an acceleration. But we are given that for this period of time that we have, it is corresponding to a time of 8 seconds. Is that 18 seconds exact? That's 18 seconds in this case. All right. So we are given the time frame that is 18 seconds. So from this point to this point, that is 18. And also we are given the acceleration of 8 meters per square second. So this is the only information that we are given. So in order for us to calculate the displacement, since we know that this displacement is equivalent to area, so we've got our displacement equivalent to area under the graph. So we are talking about this triangle in this case. We are supposed to calculate the area, and it's a right angle triangle where we have to calculate half of the base times the perpendicular height, which corresponds to the final velocity that we are not given in this case. We have from this point to this point, we know that is 18 in this case. All right. Okay, our area is area of a triangle, half base times perpendicular height. But we are limited now because we do not have the perpendicular height. We have the base from 0 to 18, which is 18. So how are we going to have this height? We say this height corresponds to the velocity v. So what you're going to do, you're supposed to calculate this velocity. From where? From the acceleration, remembering that acceleration is equal to velocity over time. The change in velocity over the change in time. We started at 0, so you're just going to use v over t. Acceleration, we are given it as 8, is equal to the final velocity that we do not know in this case over the time frame from 0 to 18, which is 18. So from there, we can actually cross multiply, because 8 is same as 8 over 1. So we can cross multiply 1 times v, which is going to give us a v. Then we've got 8 times 18. So this is 8 times 18, which is our velocity is going to be 144 meters per second. So at this point, we have got 144 meters per second. So that means the height is 144. So in order for us to calculate the area, which is the displacement, we are going to use half times the base from 0 to 18, which is 18 times the perpendicular height now, which corresponds to the final velocity of 144. That is going to give us the same answer is that one, which is 1,296 meters. Take note, this is displacement. Yes, you are using the formula for area, but you are calculating displacement. So your answer is supposed to be in meters. All right. So that is the condition that we, so as you can see, guys, we've got two options that you could have. Just use or the use of your formulas from linear motion. You can actually determine the value of S, or you can use the diagram, which is another way. You just choose which one is best for you guys. All right, so let's check another part of the question in this case, which is 1.4. So this question, it was how many marks? Let's check here. It was 3 marks. Okay, so 1.4, we are given that a heavy duty truck with a mass of 18 tons travels at a velocity of 60 kilometers per hour. That is the initial velocity or just the velocity that it is traveling with. And it collides with a bus with a mass of 5 tons traveling in the same direction. All right. So these two are in the same direction, they collide. So which means the other one is that was traveling with the greater speed and the, okay. After collision, the two objects move together in the same direction again. Okay, calculate the final common velocity of the two objects in meters per square second. No, this is velocity, so it's supposed to be meters per second after the collision. Okay, so this is what is happening, guys. Let's we are now this part of the application of momentum, where we know that momentum before is supposed, the sum of it is supposed to be equal to the momentum after, or the final. We've got initial conditions. So, okay, let me just remove this part so we can have this question clearly. We have a truck in this case and a bus. So let me just write these two. We have got a truck, okay, that is 1.4. So we have got a truck in this case with its own information. We've got a bus, okay. So we're given that for a truck, it has a mass of 18 tons and travels with a velocity of 60 kilometers per hour. All right, so we've got a mass in this case, which is equivalent to 18 ton. And if we convert to kgs, that's going to be 18,000. Remember that 1 ton is equivalent to 1,000 kilograms, which is 1,000 kgs. So we're going to multiply by 1,000. That's 18,000 kgs. And we are also given the velocity of this truck, which is at 60 kilometers per hour. So we are going to convert also these to meters per second, remembering that in 1 meter per second, we have got 3,6 kilometers per hour. So we are going to divide by 3,6. So 60 divided by 3,6. That is going to give us 16,667 in meters per second. Or you can just use a fraction if you are comfortable with that. Okay. Then for the bus now, we are given that, let's check for the bus. These two, they are traveling in the same direction, remember. All right. So what is happening now is that the bus has got 5 tons and 40 kilometers per hour. These are in the same direction. Okay, so for the bus, we are given its mass again, which is 5 tons. So 5 tons to kgs, that is going to be 5,000. You multiply again by 1,000, just like what we did previously. Then its velocity, that is at 40 kilometers per hour. We do the same thing, guys, as previously. We divided by 3,6. So if we divide by 3,6, this is going to be 11,111 in meters per second. Okay, so we have got the initial conditions in this case that we have. We've got two objects. So this is the first, which is our truck, and this is the second. All right, so let's say this is our M1, this is our V1, this is our M2, this is our V2, so that it can be clear. So you can see that these two are traveling in the same direction, which means we've got our truck 1 in this case, then the bus. So this truck is moving in this direction. The bus is also moving in the same direction, but the truck now has to collide with the bus because it's moving with a greater speed than the bus. That's why these two had to collide. So we are given that after collision, these two now, they are moving in the same direction. Okay, let's take the statement and see what happened. All right, this is what we have here. After the collision, the two objects move together in the same direction. They are moving together in the same direction, and we are asked to calculate the velocity in meters per second. Okay, so what we have in this case is that we are now having a single object because these two are combined together. So we are now having these two combined together. So what is going to happen is that for these two combined together, they are going to have the same velocity because they are combined together. And the mass is going to be the total of these two because they are combined together. So the mass is going to be the sum of the two, which is M1 plus M2, the mass of the truck plus the mass of the what? The mass of the bus. So this is what you're going to have. So this is our final mass. All right, so let's take our formula. Remember what I said? I said the sum of momentum before is supposed to be equivalent to the sum of momentum after. So before, we have got a truck here with a mass times its velocity, that is momentum, mass times velocity, plus the bus, which has got its mass and its velocity. But after now, this is momentum, this is before collision, then after collision. So after collision, we are seeing that these two, they are combined together. So we've got the final mass times the final velocity according to this condition that you're given. So that is what we had. So the question is asking us to calculate the final velocity, which is VF. So what can we do? We can simply divide by MF by MF in this case, which is going to be that. So let's write this. So which means our final velocity is going to be equivalent to the whole of this formula that we have made the subject. Okay, so we've made VF the subject in this case, which is equivalent to M1 V1 plus M2 V2, everything over the final mass, which is M1 plus M2. So you can just substitute, guys, into the formula direct, which is fine, but you can even make VF the subject, which is easier because now you just substitute your values. M1 times V1, that is going to be 18,000. So this is going to be 18,000 times 16,667, which is our V1. So it's M1 times V1 plus M2 V2, that is the momentum for the bus, which is M2 V2, that is 5,000 times 11,111, like that. Everything over the final mass, which is when these two are combined together. We say the final mass is M1 plus M2. So we're going to just add M1, which is 18,000 plus M2, which is 5,000 in kgs. So we are using our values in this case in kgs. All right, so this is what you're going to have, guys. So we can simplify this direct on our calculator. That means we are obtaining the final velocity as it is, which is going to be 15, something like 459 in meters per second. So take note, this is velocity. Velocity is measured in meters per second. Acceleration is the one that is measured in meters per square second. Okay, so that is what we had. It was actually a nice question. So there are so many ways, guys, of answering these typical questions. So we just hope with time we can have. We are going to work with different ways or different methods to attempt these typical questions. So there was actually 4 marks. 1.5, we are given that a drilling machine, with a pulley diameter of 30 centimeters is driven by a flat belt. All right, so this is driven by a flat belt. We are given its diameter of 30 centimeters. So let's just take the information. A diameter of 30 centimeters converted to meters, we divide by 1,000. Remember that a meter is equivalent to 100 centimeters. So divide by 100, that is going to be 0.3 meters. Is driven by a flat belt with a thickness. So given the thickness of the belt, which is T in millimeters. So this is 12 millimeters. So remember that 1 meter is equivalent to 1,000 millimeters. So that means we are going to divide by 1,000. So if we divide by 1,000, we're going to have a thickness of 0.012 meters. Okay. The tension in the tight side is 4,000. So a given T1, remember your tight side, that's T1, which is 4,320 Newton. And that of the slack side, okay, this question, they gave us everything, 1,500 Newton. So everything was given here. And also, we have got the belt velocity of 12 meters per second. So given V, which is 12 meters per second. All right, so this is 12 meters per second. Ignore the friction, which means in this case, we are not going to work with anything that has to do with friction. Take the belt thickness into consideration. Take note here, we are given to take the belt thickness into consideration and calculate the following. So the first part, we are given to calculate the rotational frequency of the pulley, which means in this case, we are talking about N. All right. We have got the diameter, we have got, we do not have N, we have got the velocity. Remember that in this case, let's take down our formulas. This is 1.51. Remember that velocity is equivalent to pi dn, whereby this is our diameter in meters, N is our rotational frequency in revs per second. If you're given in this case, that will be in revs per second. And we've got our pi, and this is our velocity in meters per second. So we can actually substitute our information as we are given and calculate the value of N, or we can just make N the subject since we are supposed to calculate the rotational frequency, which is N. So if we divide by pi d both sides, that means N is going to be equivalent to V over pi d. So we can substitute our V, which is the velocity in meters per second of 12, divide by pi times the diameter. Make sure that the diameter is in meters. So that's 0.3. Okay, so we are going to have our final value for N in revs per second, which is 12.274 revs per second. So this is what you're going to have. If you want to convert to revs per minute, then you're going to multiply by 60. Your answer is going to be in revs per minute. All right, so depending with what you want to write your final answer as, because you are not given any instruction, the question just asked us to calculate the rotational frequency. So you can leave the answer in any format of our choice in this case. All right, so that is what we were given in this case, okay? Now we have got, okay, I want us to check something here, guys. Okay, here, take note, we have got this. I didn't include the thickness because we're given there to include the thickness, okay? So on my calculations, I had the thickness, but on this calculation, I don't know why, what happened. Okay, so we're supposed to have our thickness there on D. Sorry for this, guys. So that means our D is going to be equivalent to the diameter, that is one we are given of 0.3 plus the thickness. Yes, I forgot this thickness of 0.012. So if we are to simplify, this must be times 0.3 plus 0.012 like this. All right, and this can give us this exact answer. Okay, so I'm making the exact answer, but you're supposed to end. So okay, so let's correct that, guys, and please so very sorry for that. Let's correct. Okay, on 1.52, we are now given the power transmitted by the belt in kilowatts. Okay, since we have the velocity and also the tensions of the tight side and the slack side, that means we can have our power in this case, remembering that. Okay, so this is 1.52. That power is equivalent to the product of the effective force or the effective tension times the velocity. So in this case, we are talking about T. So this can be written as TE times the velocity. All right. So that means our power, effective tension or effective velocity, that's the difference between T1 and T2. That's T1 minus T2 in this case. So which means we can even write this formula as power is equivalent to T1 minus T2 times the velocity. So power can be given as T1, which is 1,004. Okay, no, this is not 1,000. This is 4,320. All right, so this is 4,320 minus T2, which is 1,500 multiplied to the velocity of 12. Okay, so this is what we are going to have in this case. So if you are to simplify properly, guys, you are going to obtain something like P is equivalent to 33840 watts. Okay, but we can, okay, yes, according to the instruction here, we are now given the power transmitted by the belt in kilowatts. So let's go back here and convert our final answer to kilowatts. So 3 kilowatts, that means you're going to divide by 1,000, or you can multiply by 10 to the exponent of -3. So this is going to be 33,840 kilowatts, or just remove this zero, it's fine. Just 33,84 kilowatts. All right, so that is what we're supposed to obtain in this case. Okay, so these are the typical questions, guys, as we can see, and we actually need to revise as much questions work from your question papers. Yes, do a lot of questions that can actually help you in the exam. So that's what we had. And also make sure that you watch other videos from the playlist that we have for NETHEAD engineering, for science N3, and so forth. From Amazon African Motives, till we meet again.